Hello and welcome to section 9.5, which is on congruence transformations. So two figures are congruent if and only if there is a sequence of one or more rigid motions that maps one figure onto the other. So if you can do any combination of the translations, rotations, and reflections to a figure and have it map or end up exactly on top of another figure, then those two figures would be congruent. So I have an example here. What is a congruence transformation that maps triangle NAV, so this original one, onto BCY? And let me label these real quick. This corner down here is B, C, and Y. So you need to figure out how this original triangle right here, how does it move and end up over here? Okay, you need to figure out what steps is it taking. It appears as though it could rotate. I mean, you could try to figure that out, or it appears as though it's got to move left also. So, I mean, you just have to kind of look at it and see, what could I do to make it end up be where this one is? So, in the order it gives. So, N would have to map onto B, A to C, and V to Y. So, in that order. So, how is N right here going to end up on B? Okay, I would say it obviously has to go left. So look at N, how far is B left of it? So 1, 2, 3, 4, 5. Are V and Y 5 apart? 1, 2, 3, 4, 5. They are. A and C, 1, 2, 3, 4, 5. So then I would say translate 5 left. Okay. And if it helps you, you can put those in between points in there, if that's going to help you figure this out. And so if I was going 5 to the left here, it would be here, and 1, 2, 3, 4, 5 right here, and right here. And it would probably help to draw on the triangle. I'm just doing this to try to see, okay, I moved it 5 to the left. Now what has to happen to this triangle, the second one, to map it onto this one? How can it possibly end up there? Okay, it appears to me as though it's a reflection across this axis, just from glancing at it, but you'd want to check it out. So is this point right here, V and Y have to be across from each other based on this statement. So they're both 1 away, so that would be a reflection. Looks like here these are both 4 away, and these are both 3 away. So there you go. So then the second step is reflect. Oh, try that again. Reflect across the x-axis. Okay, so those are my 2 steps. Take this original triangle, move it 5 to the left, and then flip it here, and that would end up exactly on top of the other one. So those are congruent, and those are the 2 steps it takes to get there. And there's many different ways that you can do these. I mean, there's a lot of different steps you could take. So the other example I have here is to verify the SSS postulate. And so I have pictures here of triangles. So given that TD, this one right here, equals EN, YT equals SE, and then obviously SN equals YD. Could probably put another mark there so I know that's 3 marks. Okay, so that's given information, so I know that. And they want me to prove that triangle YDT is congruent to triangle SNE. Well, how would I know that? Going through a series of steps, and I already have it written out here, but let's just go through what I wrote. So I'm going to use these translations, rotations, reflections, whatever it takes to get me there. Okay, so I'm translating triangle YDT until points D and N coincide. Okay, look at here how this is written. D has to match up with N, right? So I'm going to move D down here until it matches up with N. And then I'm going to just go ahead and rotate it around that point until TD, this side right here, matches up with EN. So I'm just going to, I would basically take this and rotate it until this side matched up right here. Rotations and translations both preserve distance and angle measurements. Therefore, the rotation maps triangle YDT directly onto triangle SNE, showing that they are congruent. Okay, so that proves the SSS postulate, that it works. Because I can do this series of transformations and have it be exactly on top of the other one, they have to be congruent. Okay? So, bring this knowledge with you about these series of transformations. We'll talk about it more the next time I see you. Have a good night.